Now let's move on to the second technical lecture of this program, which will be conducted by Ms. Sreerekha U. Ms. Sreerekha U is Group Head, Program Planning and Evaluation Groups of VSSC. She is a graduate in Industrial Engineering from College of Engineering, Trivandrum, and postgraduate in Technology Management from Kerala University. She has undergone Space Studies program course conducted by International Space University, Strasbourg, France. She was part of ISRO delegation representing India for UN Scientific and Technical Subcommittee, United Nations Committee for Peaceful Uses of Outer Space meetings, and was a study group member for National Space Legislation Initiative by Asia Pacific Regional Space Agency Forum. She has actively contributed in critical areas such as handling policy matters of space activities, space cooperation in national and international context, budget management, and preparing a draft national space law. She will be delivering the lecture on the topic Indian Space Program Milestones and Set Goals for Future. Please, ma'am.
Good afternoon, respected teachers and my dear children. So time is 1 o'clock. I know I am standing between you and lunch, and hunger is like a butterfly fluttering in your stomach. Even I am also feeling very hungry. Hope I am right, no? So I'll not take long. So, and one more thing, after Shiju's history, which has even goosebumps are still there. I am so much inspired by his talk. I'll be talking some little bit of technical things which will be a little difficult to digest, so you need to take only less lunch because you have something which is still undigested after this. Okay, and before going to my presentation, I heard an excitement when Shiju has escaped from his presentation. I think the figure that is appearing in the screen is more familiar than Dr. Sarabhai. What is that? I don't know. Sorry? See, that's what. Yes, so dear students, so I'll be talking something about ISRO's milestones and future targets. So this slide has is already covered by Shiju, so I'll just pay homage, like on the 75th year of independence. I deem it an honor, especially on the birth anniversary of Dr. Sarabhai, to stand before you and talk about ISRO's achievements and milestones. By the vision set forth by these great visionaries, I would say the scientific visionaries. So, you know, Shiju was telling about the freedom movement till 1947, and he was in between, he was mentioning people were not knowing that they got freedom in 1947. So it took some more years for recognizing that we are, there is a long way to go. So there was a science movement, or a sort of science freedom movement happening in the country soon after independence. So these are the great visionaries who set forth the vision for the space programs in India. And Sarabhai has touched the right topic. We should understand the real problems of man. So what is the real problem of a man? If we can recognize it and try to resolve it, so that is the vision, that was the vision of space program which Dr. Sarabhai has set forth, and later Dr. Dhawan. He was also thinking in the same line that we must utilize national expertise, that we should not use outside intelligence or outside expertise. We should use the national expertise and capabilities in all our programs. Coming to the genesis of the space program of our country, which delivered rich deliverables in the last 60 years. So the importance was already mentioned. Tumba, you know why it was selected. Just 1 year previous to this rocket launch in 1963, in UN General Assembly there was a resolution or a recommendation by the UN General Assembly that the countries which are in the magnetic equator, they have lot of importance for doing the scientific experiments in the upper atmosphere. So the proper advice was given to the government, who were the decision makers at that time, because of the research work that was happening under the leadership of Dr. Sarabhai, that our country has also got a lot of importance in terms of this magnetic equator, because in two places this magnetic equator was passing, and that too in Kerala. So Tumba was selected. So there was also another place in Kerala near Kollam, but Tumba was selected as the center for initiating or nucleating the space program in the country. And you know, the space program all started, all of you might have visited the Space Museum also. How many of you have visited? Only very few. I think all of you should come and see our Space Museum, which is still the church. We are housing the Space Museum now. So I think I request to all teachers that you should make it, or you should see that the children should come at the Space Museum in VSSC. So in 1963, as Shiju was mentioning, the first rocket was launched from Tumba. So it was a US rocket in a French, US payload in a French rocket. And soon after that, we also had set our visions to possible experiments, and nucleating from that first rocket launch, we also took only very few years. Within a couple of years, we could launch our own sounding rocket from Tumba, and in between, many rocket launches happened during that period. That is from US, these Nike Tomahawk rockets were launched. Then USSR has brought the M100 rockets, and then after that France has also their Centaur rockets. All these rockets were flown from Tumba during that period when this Tumba was dedicated to UN by the then Prime Minister Indira Gandhi. And after that, you know, contemporary developments were happening across the country in space domain, and we had over the years we had gone through different phases of the space program, which we call it as the first phase, we call it as the initiation phase, which was for 10 years, 60s to 70s, where we were setting our visions, roadmaps, our objectives and goals. And there was also a need to build the capacity or the infrastructure for which are the basics for conducting the experiments. And another important thing was international cooperation. You know, we didn't have the basic technologies and infrastructure, so we have to depend on other countries who were spacefaring at that time. And of course, we acquired many technologies from US and USSR at that time, the then USSR, and of course from France. And after that, during the 1980s, so our space program was in the experimental phase, where we had conducted many experimental missions, including what she was mentioning about the SLV-3, and also some of the initial rockets like Aryabhatta, Apple and all. And during this experimental phase, we were actually prototyping the rockets and satellites and the instruments which were going inside the satellites. And during the 1990s, ISRO has entered into the operational phase, where we have developed and operationalized the PSLV, which is the present workhorse, or I would say now it is PSLV and GSLV Mark III, which is the workhorse vehicle for ISRO. And we have established many satellite services for the country, like the Indian National Satellite Communication System and the remote sensing constellations. and we could establish a wider use of satellite user base for satellites in the country, especially the data from the satellites in the country. And by this time, we also has made an institutional framework all across the country, and I'll just come to that in the next slide. And now, the present, in the beyond 2000s, we are in the expansion phase. So we have matured many technologies, we are in operationalizing it, commercially using it, and developing advanced technologies. Now we have to, all these years we were acquiring, now we have to give away what we have acquired and what we have with us now. So we are in that phase. So many innovative missions are happening for developing advanced technologies for the country, which is a technological base for the country, and newer services which we should be competitive, because many of the countries are much ahead of us. So we should be competitive, and you know, space is now considered as one of the leading economies of the world. So space is generating economy. So we should have, in order to meet the demand, the global demand, not only the country's demand, the global demand, we should remain competitive, and in order to that, we have to leverage our technology and the research expertise to others, to other ISRO, to other players who are interested. So we should build commercial solutions for that. And coming to our National Space Program organization structure, you know, Department of Space, ISRO is under Department of Space, which is directly coming under Prime Minister of India. And these are the major centers of ISRO. So we have 7 major centers. So Vikram Sarabhai Space Center and Liquid Propulsion System Center, both are in Trivandrum. And SDSC Sreerekha is our spaceport, which has 2 launch pads. URAO Satellite Center is the center which is building the satellites, and for these satellites we have to make instruments and payloads. So they are made in the Space Application Center at Ahmedabad. And the National Remote Sensing Center, which is basically they are dealing with the end use of the space applications. They are mainly getting the data, operationalizing, and then processing the data. And of late, we have added the Human Space Flight Center at Bangalore for developing the human space flight or human space flight related technologies. And apart from centers, we also have units. So IPRC is again at Mahendragiri, which is a testing center. IASU is in Trivandrum, DECO is our documentation center, and Master Control Facility and ISTRAC, both are our tracking stations for various types of satellites, including communication and remote sensing satellites. And this optical systems are being developed at LEOS, which is at Bangalore, and we have different remote sensing centers at various parts of the country. The location also, I think you have seen in the map in the previous presentation. Now, if you look at the whole space program, it is, we can say it is divided into 5 verticals. So basically, there are 4 major verticals, and of late we have added the 5th vertical also, which is the human space flight. So the first vertical is the space infrastructure. So space infrastructure is basically the assets which we are owning in space. So we have some assets. If you look at in our house also, or in your inside your bag also, you have some assets with you, know. So like that, the country is having some assets in space. So now India has built more than 100 satellites, and more than 52 satellites are the country's assets which are presently in space, orbiting in space. So they are mainly in these 4 categories: communication satellites, which are in the GSO orbits. Then we have navigation satellites, then Earth observation satellites, which includes remote sensing satellites, and the space science missions, which includes our planetary and lunar explorations. And how we can put these assets in space. So that is the second vertical, that is space transportation. So for transportation, we have different variants of launch vehicles, we call. So the first one is PSLV. So all of you might have heard about PSLV. How many of you have not heard about PSLV? Okay, all of you have heard. Somebody can say the full form of PSLV? Yes. And GSLV? Okay, very good, very good. So all of you are well aware of India's, rockets. So rockets are not the only thing under space program, so I'll cover some of the other things also. And third one is the end use, that is the space application. So these rockets and rockets are carrying satellites to orbit, and finally the satellites, they are delivering some data back to Earth. So with that, what we should do, that is what is done by the space applications. So there are different kinds of space applications which I will come later. And the last vertical which I mentioned was about the human space flight, which we added of late. And you know, what is the name of the project, human space flight? Very good. Okay, so Gaganyaan is under this fifth vertical, human space flight. So the fourth vertical is the capacity building. So for doing all these things, we need ground infrastructure. So many multidisciplinary, complex and huge facilities are required for launching the satellites, operationalizing the satellites, controlling, monitoring, everything. So for this, we have the launch pads at the Sreerekha, and we also have different tracking stations and ground stations at various parts of the country. And the equally important, other than the physical infrastructure we should also build the human capital. So for that, we have a very good, a very good strength of scientists, which is around 16,000 people working all over the country, contributing for our space program under ISRO umbrella, but there are a lot of other players also who are contributing now. And we, of course, one of the main objectives of ISRO is to motivate the 40%, which Director VSSC was mentioning, which all of you are coming under, the 40% of our population. So that is covered under outreach. And whatever the intellectual capital we have, we should share with others. So for that, we have a technology transfer. So all the technologies which we have developed basically for our satellites and rockets, we are transferring to industries for making useful products. And another major area is about international cooperation. So international cooperation is very important as far as space is concerned. So I'll come in details in a later slide. So now we'll go to the first vertical, what was happened and what was the evolution happened in the first vertical, that is space infrastructure. So I was telling contemporary development were happening at different parts of the country under space domain. So rockets and the related technologies, the design, development and all are happening in VSSC, LPSC and all. But the satellite, you know, another vertical, the satellite development activities were happening elsewhere. That was in basically in URSC, SAC, and of course in VSSC also. So there are basically two streams. So one is the communication stream, where we have, I mean, you know, our national communication satellites were named initially as INSAT. And INSAT, you know, where are our communication satellites, which orbit, you know, how many of you heard about orbits? Okay, in what type of orbit these communication satellites are placed? No, yeah, you are right, both of you are right. Low Earth orbit and geosynchronous orbit. So earlier we were putting all our communication satellites in geosynchronous orbit, but nowadays, you know, SpaceX, Starlink constellation, OneWeb, all of them are putting their communication satellites in the low Earth. So ISRO's evolution of communication satellites were like this. We have now developed satellites which have frequencies in different spectrum. I mean, we have covered all spectrums, including S-band, UHF band, C-band. So these are the various frequency spectrum where this communication satellites are working, and the data rate or the relay of data is happening through all these frequency spectrum. And you know, nowadays we are, now we are naming the satellites as CMS. The series is called CMS, it is not called the INSAT series. And we also have developed high throughput satellites in Ku band and Ka band also. So that is a kind of evolution that has happened in communications stream. Now coming to the Earth observation stream. We, you know, all of you might have heard about the first satellite, no? Which was our first satellite? So from Aryabhatta we have gone a long way. From there we have developed the IRS series of satellites, which is the remote sensing satellite basically, and we once had the largest constellation of remotes. The country had the largest constellation of remote sensing satellite. And you know, there are different kinds of instruments going inside the remote sensing satellites, which are basically cameras and radars. So initially we were doing 2-tier imaging, then we have gone to 3-tier imaging, which means 3 types of imaging systems will be there in the same satellite. So we can compare the same place with the 3 types of images from 3 instruments from the same satellite. So like that, then later we have gone to stereo imaging, then we have gone to optical high resolution imaging, which we earlier had, which also has the spatial, temporal and spectral resolution. So that is the quality of the data we used to define, the resolution. So there are three types. Spatial resolution, which I don't want to go into detail. So we'll just see that we have grown from 1 kilometer to 0.5 meter resolution capability, and temporal from 24 days to 2.5 days. That is the frequency in which we are getting the same data from the same place, and of course the bit rates. Now coming to the launch vehicle technology, I think all of you are familiar with this because you are more near to VSSC. So whatever developments are happening in VSSC, so you might be aware. So from sounding rockets, we have developed satellite launch vehicles which were called the SLV. Who was the project director of SLV-3? Any idea? No idea. Nobody knows? So it was none other than Dr. APJ Abdul Kalam. And then later we have developed ASLV, and then we developed Polar Satellite Launch Vehicle, PSLV, which is a workhorse launch vehicle. Technically we can say it is a 4-stage launch vehicle, and basically, you know, a launch vehicle is having the propulsion technologies. There are different, what is the kind of fuel used in rockets? What do you call? Sorry? Okay, so the propellants or the fuel, which there are different kinds of fuel. So we have in PSLV we have solid and liquid fuels, and GSLV, what is the third type of propulsion? Cryogenic. So in GSLV and GSLV Mark III we have we are using these 3 types of propulsion technologies, and after maturing from this 40 kilogram to 4-ton class satellites, now at present we are developing technologies which can be configured into different types of launch vehicles, or which can be configured for different types of missions, including re-entry missions. And these are the kind of what do you say, the strip below this, whatever in the below the launch vehicle, they are the new developments happening in the launch vehicle or the propulsion side. So the first one was a scramjet engine. You know, even now the sounding rockets are being flown from Tumba basically for conducting some science experiment and also for demonstrating some of our critical technologies. So one of such experiments happened just in 2015. So that is called the scramjet engine testing. So it is nothing but when a rocket is flying, lifting off, it has to carry the oxidizer along with it. For igniting a fuel, you need the oxidizer. So the oxidizer is the main part of a propulsion. 70% of the total weight of the rocket is the oxidizer. So if you can forgo that oxidizer, you can reduce the weight of a rocket a lot. So for demonstrating that, so scramjet propulsion was flown in 2015, and there are some other important missions like re-entry missions. We have flight one space capsule, the flight tested one space capsule recovery experiment. So this module has orbited Earth for 12 days and it returned back safely, and we could recover this from the sea. It is still in Space Museum, you can come and see. Then we also tested our CARE mission, which is one of the CARE module, which is one of the important precursor for our human Gaganyaan project. Then under the winged body, we have demonstrated the reusable launch vehicle, which is basically for optimizing the cost and multiple use. And of course, there are some critical technologies which are under development, basically under the propulsion, that is in the semi-cryo, other than cryogenic engine, we are now also in the under R&D stage, the semi-cryogenic engine, and also other engines like LOX methane engine and all. So they are our future technologies, future propulsion technologies. And when we look at the achievement of ISRO in the last 60 years, and coming to the current space assets which I was mentioning, there are 19 communication satellites as of now in orbit, and they cover almost all spectrum. So I was mentioning about the spectrum, so we call it as transponders. Shiju was mentioning about the DTH, so all this communication, broadcasting, weather, all these things are done through this high frequency bands through transponders in the communication satellites. And then comes the remote sensing satellites. We have 25 of them in orbit now, and they're in different types of orbits, of course. And then we have a navigation satellite. What is have you heard about the Navi constellation, or kind of GPS of India? Navigation satellite, what is the name of that? So it is called NAVIC. So NAVIC is an approved program, so I'll come to that later. Then we have the space science satellites. It is very popular, the Mars Orbiter mission, Chandrayaan 1, Chandrayaan 2, and the AstroSat. Now, coming to the launch vehicle technology demonstrators. So from GSLV Mark III, now we are, you might have seen recently about the SSLV launch, although the vehicle has, we had the maiden launch last week. So the vehicle has performed well, but the satellite was not placed in the right orbit. And we also have the next generation launch vehicles, which are with configurable propulsion stages. And these are some of the technology demonstration vehicles which are under development. RLV I have mentioned. Then we have the test vehicles, which is basically for testing our human flight related thing. And we are also dealing into, you might have heard about the Blue Origin. Have you heard about Blue Origin, SpaceX and all? Yes, what is Blue Origin? Sorry? Jeff Bezos, I understood, but what is Blue Origin? Yeah, so that is like taking tourists to space. There is a module which is commercially operated by Jeff Bezos, as he was telling. So for that we need, India should also develop such technologies for commercially operating such space tourist modules. Yeah, this was the program I was mentioning. So India, we own our own GPS system. So that is through these 7 satellites which are in orbit. So that system is called NAVIC. So NAVIC consists of 7 satellites, 4 are in the GSO orbit and 3 are in the inclined GSO orbit, and we have completed this constellation in 2018, and then now it is there are a lot of applications for this NAVIC. I think I am crossing the time. So these are some of the applications, like it has got the mapping services, precise position timing services, and there are a lot of strategic applications, and there are a lot of other applications which you will be seeing in the coming years. So some of them which were already demonstrated is shown there. And yeah, coming about how we are using our remote sensing satellite data for the development of our country. So these are the different kinds of applications. So this slide, I would say, it is a benchmark for whatever we are doing or whatever we are achieving. So we will say we have launched 5 satellites, 4 satellites, 102 satellites, 25 satellites. We have tested a new vehicle. So all these are finally culminating into different kinds of applications for the common man and also for the national development. So in 2015, Honorable Prime Minister of India, he himself has chaired one meeting, and in that he called 60 ministries, the people from various departments, they were put in one room. He was chairing the meeting, and he said, you identify what your department, how your department can benefit from space. So 160 applications were emerged out during that meet. 120 MOUs were signed with different ministries. ISRO has signed 120 MOUs with different ministries for developing applications. So that includes all these things: crop insurance, crop intensification. So all these things you might not be knowing, because these are the end use, which is the benchmark of our national space program. So these are still working. Now there are also societal applications. There are numerous societal applications which I cannot cover, but basically we are using the satellite development in these 3 areas. Sustainable development. So there are, in UN there are 16 defined sustainable development goals. So the space is contributing to all 16 under the umbrella of different types of programs in ministries. Then socio-economic security, disaster risk reduction. So, the kind of precision or the accuracy in which we are predicting the weather and also the cyclones and whatever it is. And there are a lot of other programs also which is listed there. Now I'll just mention a few achievements. Chandrayaan-1, of course, all of you are very much aware. It was launched in 2018, and all the payloads, there were 11 payloads in Chandrayaan-1, and all were built using foreign collaboration, and many agencies from other countries like US, UK, Germany, Bulgaria, all these countries contributed for making payloads for Chandrayaan-1, and there are historic and revolutionary findings from Chandrayaan-1 data. And the water molecules were found for the first time in lunar surface through this instrument in Chandrayaan. AstroSat is the astronomical space observatory which ISRO has launched, and it is still operational. And there are several findings, and these are the kind of instruments in AstroSat. Basically, the X-ray telescopes, they are contributing much for discovering many things in the universe. And you can just visit website. Last week also there was a major finding from the data which is from AstroSat. And as of now, more than 1,000 users are registered users are there, and the data from the AstroSat is published in our science data center. It is available for everybody for taking it out and research or further develop on the data. Mars Orbiter mission, I don't need to elaborate on that. So basically the Mars Orbiter mission, it had 2 objectives. The technological objective, of course, was for making an orbital module around Mars, and also for developing the technologies for designing, operating and managing a mission in the around the Mars orbit, and also in the the mission management for the earthbound phase and also for the long cruise phase from after the earthbound phase, and the third last finally the Mars insertion mechanism. So these technologies were demonstrated through Mars orbiter mission. And apart from that, the scientific objectives, it is a lot of data from the various instruments where is being delivered from Mars orbiter mission. The data is available again in the ISD, the Science Data Center, and 304 registered users are there from 50 countries which are using the MOM data now. And these are some of the major findings from the Mars orbiter mission. So even though it was designed for a life of 6 months, it has worked for more than 5 years. And Chandrayaan-2, so it was very popular. I don't need to elaborate on that. So we had one orbiter, lander, and rover. Although the soft landing of the lunar rover and the lander was not accomplished, the orbiter is still giving very precise data. So it is still orbiting around the moon. And these are some of the images from the OHRC payload, that is the optical high resolution images. So you can see the kind of crater, the 3D view of that crater in the moon. So it is the Chandrayaan-2 data is also now published in the data center. It is free to use. And coming to Gaganyaan, so our respected chairman has already mentioned about the Gaganyaan program. So I'll basically tell we are developing technologies for human rating. First of all, there are some technological elements and operational elements for Gaganyaan program. So technological elements comprises of developing or converting our present launch vehicle into a human rated launch vehicle. Then we have to develop the orbital modules for humans to travel, and also the life support systems, and the operational elements and also the technologies like spacesuit and all which we need to develop. And the operational elements comprises of developing the training centers for astronauts, simulation facilities, and the control centers, the data linking, the establishing communication links. So all such technologies are very critical and has to be looked into in detail for finally qualifying it. So all these are concurrently progressing at different parts of the country, and we are also getting help from our outside foreign space agencies in procuring some of the critical items. And basically Gaganyaan has 2 unmanned flights. It is planned 2 unmanned flights, and the third one will be the manned flight. And the time anyway chairman has already mentioned you. Yeah, finally coming to the international relations, which is a very important part as far as space is concerned. During the 1960s, if we could accomplish something today, it was only because of the foreign cooperation which we got in the initial years. So right from the 1960s and even now, we are pursuing an international cooperation with almost all the countries. Right now, earlier our cooperation was limited to a very few countries like US, USSR, France and all, which helped us in getting some of the important technologies, and later we jointly built some of the technologies through which we could master some critical technologies from outside. And during the 1980s, our satellites were launched by the rockets of other countries. Apple was launched by France. Then INSAT 1 and 2 was launched in the US rockets. And then the first Indian in space was put by, who was the first Indian astronaut? Or the only Indian astronaut? Yeah, so he was flown in a USSR rocket. And like that, in 1990s, when ISRO entered the operational phase, we had commercialized we started commercial launch services through our satellites. So many of our, we had many foreign customer satellites. Even now we are launching satellites from foreign customers. And of late, like in the 2000s, when we were in the operational phase, initially we were acquiring technologies and experts from other space and agencies. Now we are giving or extending our expertise and technologies to other non-spacefaring countries. So basically, the space cooperation includes joint missions. So we are building satellites for other countries which are not competent enough to make their own satellites. We are accommodating the payloads from other countries. Then there are joint experiments conducted. Many of the joint experiments, some of the examples are shown there. Like the Megatropics was one of the important joint satellite mission between India and France. And we are getting ground station support from various countries for tracking our satellites and launch vehicle. And of course, we are also extending our training to foreign students through capacity building programs. So Unnati was one of the capacity building program, which is a nano satellite building program extended to foreign students under UN umbrella. And you might have heard about the space sector reforms which happened recently, announced by Prime Minister, Honorable Prime Minister under the Atmanirbhar package. So under the space sector reforms, so far all the space program was undertaken by ISRO in the country or under the government, we can say under Department of Space. Now under the space sector reforms, the government will enable the private industries to carry out their own space activities. So if a private industry or if a student or a school, if they want to launch their own satellite, they can be given permission and they will be given all support. So these are the mechanisms for that. So when we are enabling a private industry, we have to monitor them, regulate them. We have to, because the country is liable for any incident happening. So this regulation and authorization, at the same time technological support is also given through infrastructure sharing. That is, we will share ISRO's facilities to private industries. Then we will handhold them by giving technological support. And we are also doing a promotion of space activities through this mechanism. So a new body was formed, which is called the Indian National Space Authorization Center, which is acronymed as INSPACE. And INSPACE headquarters was recently inaugurated by Honorable Prime Minister at Ahmedabad. And apart from this, there is a commercial wing for ISRO called the New Space India Limited. And ISRO will continue developing advanced technologies for the development of the country. Now, I think I have already past time. So these are the kind of hand-holding which we are giving to industries under the space sector reforms. And finally, the concluding slide, that is the road ahead, what we are planning to do in future. So the first one is assured access to space is a critical goal for a country's development. So we have to do that assured access at a reduced cost. So that is one of our goals in the future. Then we have to augment our present constellation with the high resolution hyperspectral satellites with the geoimaging capability. Then under communication, we should have all these technologies which will make India competitive. And under navigation, we should have enhanced global constellation. And for building capabilities, we should also build capabilities for more science exploration. We have to pursue our human space program under, by extending the Gaganyaan and beyond. Then at the same time, we have to share the technology and expertise to private industries and also to other non-spacefaring nations. Now, some student-specific programs. So somebody was asking in the morning to Chairman ISRO regarding what program you have for tribal students. So I think Jawahar is not there. So Sir Shiju and Jawahar, they have gone to all the tribal areas of Kerala and even to Tamil Nadu, covering many schools. There are more than, as Sir was mentioning, more than 100 scientists have reached the tribal area. They have to, in fact, they had to walk for kilometers. I think Jawaharji was mentioning, I think he's not here now, he was here. He has walked 11 kilometers to reach one school for taking class. So these are some of the student-specific programs of ISRO. The Yuvika, you might have heard, recently one program is over. Then Unnati was the nano satellite building program especially for students. Then World Space Week, sir was mentioning in the morning, every year it is happening from October 4th to 10th. So various student-specific programs are being organized by all ISRO centers, especially in Kerala, all across the state. So we are reaching to schools during that time. And we also have celebrated the Vikram Sarabhai centenary programs. Many student-specific programs were covered under this. And coming to the ISRO Academia interface, these are the programs which ISRO have currently. So we have sponsored research programs at different universities. We have space technology centers at premium institutes and colleges. Space technology cells are also being supported by ISRO at various institutes like IITs and IISc. Then we have, the strategies for future are listed there. So basically we are targeting all these things. And the spin-offs, so finally, the technologies which are basically developed for rockets and satellites will find use in some other applications. So these are some of the major technologies which we have transferred to industries, which was successful in various other areas. The lithium-ion technology, the lithium-ion technology which was basically used in electric vehicles. So ISRO was using these cells, lithium-ion cells, for our satellite and launch vehicles. So this we have transferred. So such technologies are listed there. So you will get more details from Robin, who is heading that division. So with that, I am concluding and wish you all the best and wish you a happy Independence Day.
To present a memento to Sreerekha ma'am as a token of appreciation.